All right, welcome to section 9.2. This is the third of our 4 conic sections. This is the ellipse. Ultimately, what it looks like, but it isn't. It's not its definition. It kind of looks like a circle in that you still have the x minus h squared plus y minus k squared. But now we have this introduction of a and b values that stretch what is now an ellipse, either vertically or horizontally. So it kind of looks like oblong, I guess. For our purposes, and the future classes will go into more detail, it's a collection of points. So x, y is all the things kind of on the edge of this, what looks like a squished circle, where the sum of the distances from two fixed points, these are the foci, whatever you want to call them. There's multiple ways to say this. They're constant. So ultimately, we have these 2 points. If you take a look at where these 2 points are located, I'll go ahead and mark them in, let's choose yellow. So if you take a look at this point here in yellow and this point here in yellow, ultimately what an ellipse is if you have these 2 points at specific locations, very specific locations, if you choose any point on the actual ellipse itself, then the distance from each one of those, if you add them together, is the same, regardless of what point you choose. So if you choose a point over here, then the sum of the distances is the same. If you choose a point anywhere on it, then the sum of the distances is going to be the same. Now, as with the parabola, where we had a ton of information kind of dropped on us, and circles, same type of information we had before, the ellipse has more stuff going on as well. So now we have a couple of different things. We have the center, which is identified in red. The center location is still identified as HK. So we can write that off to the side. So we know that the center is still HK, which we'll be able to find from our equation, or be given the information to find an equation based off of that. Then you'll see that it looks like this thing has been stretched further. So this picture specifically looks like it's been stretched further in the x direction, so horizontally. So if you go from the center and you go all the way out to that vertex. So vertex is the point, there's 2 of them, that is stretched out further in either vertically or horizontally. In this case, it's horizontally. So we're going further in the x direction than we are in the y direction. That distance is identified as A, as you can see in the picture here. Well, it's the same if you go to the left also. So that distance is also A. Then we have our co-vertex or co-vertices. This is how much it's stretched in the other direction. So if we were already stretched major in the x direction, then it would be minor in the y direction. So this co-vertex, and each vertex is a location. So a co-vertex is a point on the actual ellipse itself. Then we have the length of the major axis. Okay, major is where it's been stretched the most. So if we take a look from the center and we went left and then right, that entire distance right there from vertex to vertex, that is the length of the major axis. Then, if we were to take a look at the distance to the co-vertex, and we found that entire distance, that would be the length of the minor axis. Minor because it's just not as long as the major. And then we'll be able to find those from the equation themselves. So, the foci, however you want to say it, those are a specific distance, and that distance is called C. So if this distance here, so to these little purple points, that distance to each one of those is going to be a distance of C. We'll also be able to find that using some information from the equations. We're just kind of taking a look at the nuts and bolts of this thing. And then I think we're ready. We'll take a look at what this equation looks like. Again, it kind of looks like a circle. So if we take an ellipse that has a horizontal major axis, so it's been stretched more in the x direction, so stretched more in the x direction, then we know that that blue length is going to be the length of the major axis. So from center to the right, from center to the left. We also know that the length of the minor axis is going to be from center up and from center down. So distance from covertex to covertex. We also know that where the foci are located is always on the major, always. So important to note, those locations are always going to be on the major axis. It doesn't matter if the major is horizontal or vertical at all. Okay. Well, the equations to these look almost exactly the same. Here's what I think. I see what looks like a circle. So if I were to just take a look at the stuff on top. So ultimately, I see what looks like a circle. I see x minus h squared plus y minus k squared. It's still a plus. That hasn't changed. This whole introduction of A and B, this just tells you how far you're stretching in each one of the directions. It's important to keep in mind, too, that when we're talking about an ellipse, that what you're looking at with the denominator is that A is always bigger than B. So whichever one of these, the x or the y, has the larger denominator, that's where you're stretching more. So that's where your major is going to be. So if I were to take a look at this equation and I find where the A is, so the bigger denominator, then I know it's going to be stretching more in the x direction because it's underneath the x. So this is a horizontal major. Whereas if I take a look at this one down here, my vertical major, I'm still going to look for the bigger denominator. Well, the bigger denominator in this case is underneath the y. That means that the y is the major. So we're stretching vertically this time. Okay, so we have a squared and b squared. Do keep in mind that everybody is squared here. Big major difference as far as I'm concerned when it comes to circles and ellipse is that you want this equal to 1. You don't want this equal to anything other than 1 to get it in form. So I did say that you'd be able to find the location of the foci. Well, you can. It's kind of a version of the Pythagorean theorem. No, it's not a squared plus b squared equals c squared. If it was plus, then c would be outside of. So the distance from the center would be greater than a and b. But I want the distance from the center be smaller. So by subtracting, I know that the location of C is inside the ellipse. And I say inside because if I take a look over at, let's take a look at the vertical major one to the right here. If I were to do a squared, so we've got A, so there's A squared plus B squared, and I calculated C squared by doing Pythagorean theorem, then this distance of purple would be larger than the distance of blue or teal, which means that my purple would end up being somewhere outside the ellipse. I don't want that. I want it to be inside. So what I'm going to do is I'm going to do the a squared, b squared, but I want the distance to be less so that I can stay inside. So I'm still going to take a squared and b squared, but instead of adding them together, making the distance or making c located outside, I'm going to do a squared minus b squared so I can keep that c located inside. All right, let's actually do some examples here. Okay, so I have this equation that I want to put in standard form. Well, standard form is that x minus h squared plus y minus k squared equals 1. And then x squared and y squared have some denominator, whatever it is. There's something there, though. Oh, even if there isn't anything there, it's technically a 1. Okay, so let's put in standard form, identify the vertices, foci, center, and sketch. Okay, I'm going to reorganize stuff. I want to have my x squared and my x right next to each other, so I'm going to reorganize these two to go together. And then I want my y squared and my y next to each other, and I'm going to go ahead and put my constant on the other side. Okay, from here, we want the coefficients on the x squared and the y squared to be 1, so I'm going to factor out what I've got here. So this is 9x squared minus 6x, and then plus 4y squared plus 10y equals negative 37. Okay, now I need to complete the square. So I'm going to go ahead and do my x squared minus 6x off to the side. Actually, we'll do it right underneath. So let's do, and if you need to draw the box, go ahead. I will not always draw the box. I'm only doing this for notes. Okay, so the number I know that it needs to complete the square here is going to be a plus 9. So here's what I'm going to do. I'm just going to extend these parentheses down. So I want to include a plus 9 inside those parentheses. Now, make sure that you pay attention to what you're adding to both sides. So right here, I just put in a 9, that times a 9. So I need to add that 9 times 9 to the other side. So I'm going to do plus 9 times 9. And those are the orange boxes I put on the other side. Okay, we'll get back to the factor form in just a second. Let's go ahead and do the y's. So I'll do y squared. Cut that in half, 5y. That's going to give me a 25. So I'm going to do the same thing. I'm going to extend these parentheses down just a little bit. So I'm going to put a 25 in there. So that's going to complete that square. Okay. So that means I'm going to have a 4 and a 25. So I'm going to do plus 4 times 25. That takes care of those two. All right, so now I'm going to go ahead and go to factored form. So I'm going to bring down, so I'm looking back at my x's. I'm going to bring down my coefficient of 9. Remember, this is going to be x minus 3, so that's going to be 9x minus 3 squared plus, okay, bring down my 4. This is going to be y plus 5 squared equals, okay, now combine like terms on the other side. So let's go ahead and add these together. So it's going to give me negative 37 plus 81 plus 100. So 144. Okay, so now if this were a circle, we would stop here. It's clearly not a circle, though. I can tell just by looking at this, the fact that there are numbers in front of my x squared and my y squared. Like, that's a dead giveaway. Those numbers are not the same. If they were exactly the same, it's a circle. But they're not exactly the same, so it's not. So I need to go through, and I need to make this equal 1. Well, to do that, I'm going to go ahead and just divide by 144. And everybody's going to get divided by 144. Now, interesting to note here is that when you divide, so if I divide this whole thing right here, you really only need to divide the 9 and the 144. You don't want to divide more than that, because that would be dividing by more than 144. You'd be dividing by multiple 144s. So if I do 9 divided by 144, now I want all of the numbers in the bottom. So I'm not going to actually do 9 divided by 144. I'm actually going to do 144 divided by 9. So when I do this division off to the side, so just so you can see what I'm doing here, is I'm doing 144 divided by 9. So I want all of the coefficient or number to be in the bottom. Well, when I do that, I'm going to get a 16. So let's do x minus 3 squared all over 16 plus, and then I'm going to do the same thing here. I'm going to divide the 4 and the 144, but I'm going to reverse it because I want the number in the bottom. So that's going to give me y plus 5 squared all over 36. And then the last one is dividing the 144 and the 144, which is equal to 1. Okay, what do I know so far? Well, I know what the center is for sure because I'm looking at the HK right now. So my center is going to be 3 comma negative 5. I can also take a look at the denominators right now and figure out which one this is. So what's it stretching and in which direction? So I'm going to take a look at my denominators. I'm just going to look at 16 and the 36. The one that is the biggest one is a squared. So I know that 36 is going to be a squared. Let's pull down the size of that pen. Okay. So I know that a squared is equal to 36, which means a is equal to 6. So from the center, I'm going to go 6 units up in the y direction to find the vertex and 6 units down to find the vertex. Then I know that the other denominator, which is the smaller one, need to pull that pen down as well, that is going to give me my b. So b squared is equal to 16, which means b is equal to 4. Even if you're not sure which one is a and which one is b, just the bigger number gives you the location of the vertex. So if you're like, which one's a, which one's b, it doesn't really matter. You just need to know that one of them, the larger one, is the one for your major. And just pay attention to what direction you're going in. So my a value came from the y, so I'm going to go more in the y direction. And my b value came from the x, so I'm going to go less in the x direction. Okay, I think I'm going to go ahead and start sketching this, try to get some stuff on here so we can make heads or tails out of what's going on. So go ahead and set up your axes here, and then let's get some points plotted. Okay, so I have my 3, -5 marked on my graph. Now I'm going to use my a value of 6, and I'm going to go in the y direction 6 units directly from that point. So I'm going to go down 6, 1, 2, 3, 4, 5, 6. And I'm going to go up 6, 1, 2, 3, 4, 5, 6. Each one of these is a vertex. So from here, I can go ahead and identify what those are. So my vertices, what I did was I took my center, 3, -5. And I went up and down 6 units. Up and down affects the y value. So I went up and down 6 units. That's all I did. Okay, well, let's do the math. So my vertices are going to be 3, -5 minus 6 is -11. And then -5 plus 6 is 1. Those are the locations for each of my vertices. But all I did was go from the center and go up and down 6. Okay, let's do the same thing with our b value now. So my b is in the x direction. So go back to your center. I'm going to go right 1, 2, 3, 4. That is a covertex. 1, 2, 3, 4. That is also a covertex. So to find my covertices, I took my center and I went right and left 4 units. So right and left 4 units. Okay, so let's see. 3 minus 4 is -1, so -1, -5. 3 plus 4 is 7, 7, -5. These are the locations of my covertices. Okay, the next thing I need to do is I need to find where the location of the foci is. Remember, we want to be inside. So to be inside, what I'm going to do is I'm going to take c squared. We might have to do a little bit of work to get c itself, but not a ton of work. I know that c squared is going to be a squared minus b squared. Well, a squared and b squared come directly from the equation. So a squared I already identified as 36. B squared I already identified as 16. So I know that c squared is equal to 20, which means c is plus or minus the square root of 20. You can simplify it if you want to. I'm good if you don't. What this says is that you are going to start at the center. So I'm over on my picture, and I'm going to go up and down the square root of 20 from there. Okay, well, the square root of 20 is between 16 and 25, so it's 4 and some change. So if I go up 1, 2, 3, 4 and some change, that location right there, that is going to be one of my foci. So 1, 2, 3, 4 and some change, that location right there is one of my foci. So what did I do? Okay, well, to find my foci, I started at the center and I went up and down C, which was the square root of 20. Now, if this math can be done, I would do it, but there's nothing to do. We can't actually add them, so I'm just going to color code this all purple. Those are my two. Remember that these can be written as two separate things, so it's 3 negative 5 minus root 20 and 3 negative 5 plus root 20. I think we've marked everything off the list. Let's just give it a quick sketch. So remember that the foci are inside, so you're going to go vertex to covertex, covertex to vertex, up, and then loop back around. That's it. Okay, we do have another example here. It's kind of in the opposite direction though, so you're going to have to come up with the equation yourself. So what you might want to do is pause, see what you can identify so far, consider putting stuff on the graph, and then come back and go along with me. Okay, so I set up my graph, and I'm just going to go ahead and start marking things in the picture. So I've got 5, 6 and 5, negative 4. So let's go ahead and plot those on the graph. Okay, as I go through, I'm going to figure out what information I can actually get. Well, I know right now that if the vertices are vertical, so if they're up or down, then that means that I'm getting a major axis or stretched more in the vertical direction. So I know that a squared is going to be underneath the y, but I also know that I can find the center right now. So I'm just going to count. So if I'm at 5, 6, and 5, negative 4, then I know that my center is going to be at 5, whatever the middle is between 6 and negative 4. So you can just average it. So it's going to be 5, looks like we're at 1. Okay, so now I just found HK. There's H, there's K. So I know that 5, 1, that is where my center is located. Oh, I also know now that I know how long A is, because A is that distance right there. So that's 1, 2, 3, 4, 5. So I know that A is going to be equal to 5. All right, so A equals 5, which means when I put into the equation, A squared is going to be equal to 25. Good to know. All right, foci are located at 5, 4 and 5, negative 2. Okay, so let's see. So 1, 2, 3, 4, 5, 4, 5, 4, 1, 2, 1, 2. Okay, I know that this is a focus and this is a focus, which means I know that this distance from center to focus is C. So I know that C is 3. Okay. So I know C is 3, which means C squared is 9. I think I can just find B squared right now also. So remember that C squared is equal to A squared minus B squared. So let's go ahead and plug in our stuff. So I know that C squared is equal to 9. A squared is equal to 25 minus B squared. We can go ahead and solve this pretty quick for B squared. I think B squared is going to give us 16. Oh, so B squared is equal to 16. Okay, so that means that B is also equal to 4. All right, so we can put that on the graph. So B is equal to 4. So from the center, 1, 2, 3, 4. Let's get rid of that extra dot. And then 1, 2, 3, 4. Okay, so that's a covertex. That's a covertex. I think we're ready. Okay, so we're going to do x minus h squared. So that's x minus 5 squared over, we'll get back to that in a second. And then y minus k squared over, we'll get back to that in a second. And that's 1. Okay, now we're stretching more vertically, which means under y, the vertical, we're going to put a squared. Under x, we're going to put b squared. So bigger number under y. All right, so we have x minus 5 squared all over 16 plus y minus 1 squared all over 25 is equal to 1. And I think that's our answer. Okay, last one. Oh, do we need to sketch this? Nope, didn't have to. All right. So last one here, when an architect wishes to design a large room 100 feet long that will have a whispering gallery. The ceiling of the room has a cross-section that is an ellipse. All right. If the foci are to be located 32 feet to the right and to the left of the center. Okay, so that means that it's being, it's got a major that's a horizontal. Find the height h of the elliptical ceiling. All right, well, let's see. I would start identifying stuff that I know based off of the picture. So it looks like my center is at 0, 0. I also know that my vertices are going to be at positive 50 and negative 50. Okay, so vertices are at negative 50, 0 and 50, 0, which means A is equal to 50, which means A squared is equal to 2,500. Okay. Co-vertices, I'm not quite sure yet, but I do know C. So my foci are at negative 32, 0 and 32, 0, which means C is equal to 32, which means C squared is equal to 1024, if I multiplied that out correctly. Okay. If I know that, then I can find b squared. So just a reminder, c squared is equal to a squared minus b squared. C squared is 1024. I know what a squared is. That's 2,500. I don't know what b squared is. I'm trying to find that. So b squared is going to give me 1476, which means b would be the square root of 1476, whatever that is. Find the height h of the elliptical ceiling. Okay, well, let's see. I think we just found it. Actually, 1476, which in this case is what? Feet. We could actually go ahead and write the equation. May as well since we're here. So we know it's going to be x minus 0 squared over something plus y minus 0 squared over something. It's being stretched more in the x direction. So that means that the longer stretch is underneath the x and that the smaller stretch is going to be underneath the y.